Hello everyone, me Vakıf Aliyev. So we are gonna talk about Python task. So there are 17 tasks in the Jupyter notebook. So I am gonna explain every single cell in this assignment. So let's start. Firstly, I import NumPy and pandas, which I will use for data processing, and matplotlib for all the data visualizations. So I also activate matplotlib inline, the percentage matplotlib inline, so that all the plots appear directly inside the notebook. After that, because I am working in Google Cloud, I use the files upload function to upload my dataset. Once the upload is complete, Google Cloud automatically saves the file and prints the file name that was uploaded. So let's try it. Yes, it is our dataset. Yes, we run it successfully. So finally, I define the file path as the file which was named mdb top 1000.csv file, and load the dataset using pd.read underline csv function. And this creates a data frame called mdb, which I will use throughout the assignment for all analysis and the tasks. Let me check. Yes. So let's start. Yes. After that, we can start from the first task. The first task is print out columns, then rename them however you wish, make them simpler. Drop delete poster column, show first 3 rows, and here's the code. As you see, this code, let me make it bigger. Yes. I start by printing the column names of the dataset just to see how they are originally defined. Most of the column names in this dataset are long and not very convenient to work with. So the next thing I do is rename them to shorter and simpler names. As you see, I'm in this part. For example, series title becomes title, and another example is release year becomes year. IMDb rating becomes rating. It's just simpler, and so on. And this makes the data frame much easier to use later when writing functions and doing analysis. After renaming, I remove the poster column. That's why I use drop function. The poster is just an image link, and it is not useful for any numerical or statistical tasks in this homework. So I drop it completely. And finally, I display the first 3 rows using IMDb header 3 and first 3 rows. And this helps me confirm that the renaming worked correctly, and the poster column is removed and the data frame is clean and ready for the another task. For example, the second task. Yes, sorry. Let me run it firstly. Sorry. Yes, it works successfully. So let's start with the second assignment. Show relevant statistics about the data, for example, 5-number summary, and explain what you understand from this summary. Yes, I use for that reason I use IMDb describe function to get an overview of all numeric columns, including the count, mean, standard deviation, and the k percentiles. Right after that, I extract the five number, the summary, the minimum, the 25th percentile, the median, the 75th percentile, and the maximum using dot log function selection. Let me run it. Sorry. First, yes, as you see. Let's keep continue with the third task. So analyze your data. Is there missing null or incorrect values? What are they? And are they imprecise data types? So task 3. Yes, sorry. Let me delete it. Yes. In this cell, I analyze the dataset for missing values and incorrect data types. That's why I began by using IMDb is.sum function to check how many null values exist in each column, and it helps me identify where the dataset needs cleaning. Then I check IMDb D types to see whether any of the columns are stored in the wrong data type. For example, numbers stored as strings. And after that I start cleaning the dataset. For example, the gross column originally contains commas and sometimes dollar signs, which prevent it from being recognized as a numeric value. So I convert it to a string, remove the extra characters, and then turn it into a numeric, how can I say, column. Let's run it. Yes, it's the first part of the third task. Next, I clean the runtime column, this column. Runtime values come into the format 120 minute, so I remove the minute part and convert the remaining value to a number, as you see. So let's continue. The year column. Sorry. So I also convert. Let's run it first. Yes. I also convert the year and meta columns to numeric types using pt.toNumeric, which automatically handles any problematic values. Let's run it also. this part. Yes. And finally, I fill in the missing values. For Metascore and runtime, I use a median because it's a stable measure that is not affected by outliers. For the gross column, I fill missing value with zero. With zero, since I'm missing gross, usually means no recorded box office data. And for the year column, the year this column, I replace missing values with zero as well. And finally, after this cleaning process, all of the k numerical columns have consistent and usable data types, and the data set is ready for deeper analysis in the next assignment, the next task. So continue with the first task. Generate statistics again. What new do you see? What does it tell you? So I generate the descriptive statistics again, but this time after cleaning the dataset. For the first task. Now that the incorrect data types and missing values have been fixed, the summary is much more accurate. Let me run it. Yes. Let me try it first. Yes. Here's our statistics, and the numeric columns such as gross, runtime, year, and finally show valid statistics like mean, standard deviation, and proper minimum and maximum values. Because let me check. Because the missing values have been handled, the counts in each column are now consistent, and we did it in the previous task, and the minimum and maximum values also make more sense since the next formatting issues were removed. Overall, the distribution looks much cleaner and more realistic, and this confirms that the data set is now properly prepared for the next task. Let's keep continue. It's our fifth task, and I wrote a function called top movies that returns the highest rated movies from a specific year. The function takes four parameters: the data frame, the year, and we want to filter by the number of the movies in, and the parameter called by, which allows me to choose whether I want to sort by IMDb rating or by Metascore. Inside the function, I first check whether the by parameter is valid. It must be either rating or meta. And then I filter the data frame to include only movies released in the given year. After filtering, I sort the movies in descending order based on the chosen rating type. Finally, I return the top n rows using 8n. At the bottom, I test the function by requesting the top 5 movies from the year 2010, sorted by IMDb rating. These functions will be useful for the next task. Here's our assignment, our output after calling the function. Let's continue with this part. Let's run it firstly. Yes. I use the top. Sorry. Top. Yes. I use the top movies which we created before in the previous cell, and this is the functions that I wrote earlier to find the highest rated movie of their every decade. And I start by creating a range of decades going from 1900 up to 2030, stepping by 10 years. Each value in this range represents the starting year of a decade, such as 1900, 1910, 1920, and so on. Inside the loop, I call the top movies function and ask for only one movie, the top movie from each decade. The function filters the dataset by year and returns the highest rated film for that period. Since some decades may not have any movies in the dataset, I include a check to make sure the result is not empty. If there's at least one movie, I print the decade and the title of the top film. This gives me a quick overview um, to that data set. Let's run it. Yes, it worked. Let's keep moving to the first. Let's run it. Yes, I created a function that finds the most commercially successful directors. Success here is measured by a uh, total box office. Total box office. Sorry. Yes. In this assignment, I grouped the dataset by the director column and calculate the sum of the gross revenue for each director, and this gives me the total earnings of all the movies directed by each person. After that function, I sort the results in descending order, so the highest earning directors appear at the top. And finally, I use return function d.hit bracket n. At the bottom, I call this function by using the input IMDb and 5, and here's our output, and our data type is float 64. Let me check. Yes. James Stewart. It's our output. Yes. A top movie is defined as one that has an IMDb rating of at least 8 and Metascore of at least 90. So first I filter that dataset to include only the movies that meet both of the conditions. Then I collect all the actor names from the 4 actor columns, star 1, star 2, star 3, and star 4. I simply loop through these columns and add all of the actors into a single list. After that, I converted the list into a panda series, as you see, and use a value count to count how many times each actor appears. Finally, I return the top entry. Which tells me the actor who has starred the most frequently in highly rated, critically acclaimed movies. At the bottom, I called the function, and here's our output. So let's keep moving. Here, a commercial success is defined by total box office revenue. In other words, the sum of the gross earning of all the movies and actors appears in. To compute this, I loop through every row of the dataset using the iter rows. For each movie, I read its gross value, and how can I say, and then go through the 4 actors columns: star 1, star 2, star 3, and star 4. For each actor, I add the movie's gross revenue to the total. Then I store this total in a dictionary where the K is the actor's name and the value is their cumulative box office earnings. After processing the entire dataset, I convert the dictionary into a panda series and sort it in descending order. Ascending first is equal to descending order. And then I simply return the top n actors using head n. Finally, I call the function by using the input IMDb, and n is equal to 5. It is for getting the top 5 commercially successful actors, and it gives a clear ranking of which actors have generated the largest total box office revenue based on the movies in the dataset. I'm in this part. It's our output by using this input inside of the function. Let's keep moving. Yes, the function. I created a function called best by genre, which finds the highest rated movie for a given genre. The function has 3 arguments. Let me check. Has 3 arguments besides the data frame. The genre we want to search for, a by parameter that lets me choose whether I want to sort by IMDb rating or by Metascore, and a single flag. A single flag is crucial and important because some movies have multiple genres. If single is set to true, the function only considers movies that belong to exactly one genre. For example, movies that are strictly labeled as comedy and not comedy drama. If single is false, then any movie then any movie that includes a given genre is accepted. Inside the function, I filter the dataset using a lambda expression. Depending on the single flag, the condition either checks for the movies with exactly one genre, or movies where the genre appears anywhere in the list. After that, I sort the results in descending order by using ascending is equal to false order based on the selected rating type. Yes, rating type. Either IMDb rating or Metascore, and finally I return the top movie using the input d.head1, and finally I called best binary genre function by using the input IMDb comedy by is equal to rating and single is equal to false. Yes, it's our output. Yes, it's our output. It was run successfully. Let's moving. Yes. In this task, I worked with movie genres. The goal is to extract all unique genres from the dataset and then use the function I wrote earlier to print the best rated movie for each one. I start by taking the genre column which contains a list of genres for each movie, and I use explode to turn the list into individual rows. It allows me to get every single genre separately. Then I remove any missing values with drop now function and call unique function to extract only the distinct genres. I store this result in the variable g, and after that I loop through all genres in g, and for each genre I call the best by genre function which we created before. I choose to sort by IMDb rating, and I set single to false, which means I consider any movie that contains the genre, even if it has multiple categories. Inside the loop, I print the genre and the title of the movie for that category. This gives me a complete list showing the highest rated movie for every genre represented in the dataset. And that's all, and our output. Let's keep moving to 12. First run it, yes. Let's get it back, and let's keep moving forward. In this task, I wrote a function to determine the most common movie genre within a specific decade. A decade is represented by a static year. For example, 1970 for the 1970s, or 1980 for the 1980s. Inside the function, I first filter the data frame to include only the movie released between the given decade and the decade plus 10 years. It gives me all films that belongs to that 10-year period. Next, I take the general column and apply explode function to break the general list into individuals entries. It lets me count each genre separately. Then I use value count function to count which genres appear the most often in that decade, and I return the top one. At the bottom, I call the function for the 1970 and then 1980 to see which genres were most common in those two periods. It helps me to show how movie trends shift over time, and some decades may be dominated by drum other by action or thrillers, depending on what was popular during that period. Let me run it. Yes, drama 5, name count, genre, drama, etc. Let me take it back and let's keep moving. Yes. In this cell, I wrote a function to find the create movies that are not very well known. The idea is to look for films that have a high IMDb rating, but a relatively small number of votes, meaning they are high quality but not widely watched. Firstly, I filtered the dataset to select movies with a 20,000 votes or fewer and an IMDb rating of at least 8. These conditions ensure that the movies are well rated but have not been seen by a large audience. The function also includes an optional parameter called use meta. If use meta is set to true, I apply another filter that keeps only the movies with a metascore of 90 or higher. It lets me focus on films that are highly prized by critics in addition to being well rated by viewers. Finally, I return a subset of the data frame that includes the title, rating, number of votes, and metascore. At the end of the cell, I tested the function by calling the grid not known function with use meta is equal to true. So I only get grid but lesser known movies that also have strong critic reviewers. Let's run it. Yes, it worked. Let's keep moving. Yes. In that assignment, in that task, I wrote one of the most detailed function. A function that returns a full set of statistics about a specific director. So I start by filtering the dataset to include only yes. I start by filtering the dataset to include only the movies directed by the person whose name is passed into the function. If the director does not exist in the dataset, I simply return none. Next, I construct a series that combines each movie title with its released year, and it gives a clear timeline of the director's work formatted as movie name, year, and after that I identified the highest and lowest rated movies by finding the maximum and minimum IMDb rating in the filtered data frame, and then I extract the title of the movies that have those exact ratings. If multiple movies share the same rating, the function returns all of them. I also compute several averages: the average IMDb rating, the average Metascore, and the average runtime of all movies by the director. These metrics give a quick overview of the director's general performance and style. Then I calculate the total box office revenue by summing the gross value, and this value across all movies. It shows how commercially successful the director has been, and finally I get all genres. that the director has worked in, and I use explode function to split the genre list into individuals in tries, and then extract the unique values. At the end, I return all of this information as a dictionary that contains titles with years and worst movies, average, total gross, and the list of genres. And below below the function I call it for Christopher Nolan. It is just an example uh, to show the output. It's our output, as you see. Let me try it again. Yes, it worked successful, and let's keep moving to our visualization, data visualization. And in that, let me check it firstly. Yes, it worked. In that task, I created a function that generates a histogram showing how many movies were released each year within a selected time range. And the function called there is hist, and it takes three arguments: the data frame, the starting year, and the ending year. Inside the function, I filter the dataset so that it includes only the movies whose release year falls between the given start and end values. It creates a subset of the data that matches. That suits the time period I want to analyze. Then I use plot.hist on the year column to plot a histogram. Each bar in the histogram represents a specific year, and the height of the bar represents how many movies were released. Let me show the statistics. The height of the bar represents how many movies were released that year. I also add labels for the x-axis and y-axis to make the chart clear. And I attached a title that shows the selected year range. At the bottom of the cell, I call the function with the range from 1980 to 2000, which displays the histogram for movies released during that 20-year period. And here's our statistics, as I explained before. Let's keep moving. In this cell, in this assignment, I wrote a function that creates a bar chart showing how many movies each director has in the dataset. The function is called director bar. Let me check here. Bar, and it accepts two arguments: the data frame, firstly a data frame and the numpy array containing the names of the directors we want to analyze. Inside the function, I loop through each director name in the numpy array. For each one, I count how many rows in the dataset have that director's name, and this count represents how many movies the director has in the IMDb top 1000 dataset. I store all of these counts in a list called counts. Next, I create a bar chart using plot.bar function, where the x-axis shows the director names and the y-axis shows the number of the movies associated with each one. I also add axis labels and a title to make the chart clear. The ticks rotation is set to 45 degrees, so the names don't overlap and are easier to read. At the bottom of the cell, I prepare a numpy array with three director names and call the function. and it generates a bar chart comparing the movie counts of, for example, Christopher Nolan, Steven Spielberg, and Quentin Tarantino. Let's run it if it works or not. Yes, it worked. It was run successfully. If I'm not mistaken, it's our last part. Yes, it's our last task. Yes, let me read it. It's our last and biggest task. So find the plot correlation between columns, year and gross, year and runtime and gross, rating and gross, rating and runtime. Explain for each case why we may see such result. In that task, I analyzed several relationships between different numerical columns in the dataset. For each pair of variables, I create a scatter plot to visualize the relationship, and then I calculate the correlation to see how strong that relationship actually is. Sorry. After each plot, I explain why we might observe the pattern shown in the graph. First, I look at the relationship between year and gross. I created a scatter plot with the release year on the x-axis and gross earning on the y-axis. Then I print the correlation value. In most cases, this correlation is weak or moderate. Older movies tend to intend to have lower nominal grosses, while newer movies benefit from a larger market and higher ticket prices. But there are many exceptions, so the relationship is not very strong. Next, I analyze year and runtime, and here I checked whether new movies tend to be low to be sorry I just checked the new movies tend to be longer. The correlation is usually small. Runtimes don't depend strongly on release year, although modern films sometimes trend slightly longer. The spread is very wide because runtime depends heavily on the genre and style. Then I analyze runtime and gross. This correlation is also weak because very short and very long movies can be less common, and mid-length movies after movies or sorry mid-length movies often dominate the box office, but overall runtime alone doesn't determine commercial success. Uh, so so yes, it works. Sorry for interruption. Yes. The other factors like franchise popularity, marketing, and orcas play a much bigger, how can I say, role. And I am deliberating on growth. This scatter plot usually shows a weak to moderate correlation, and some highly rated movies succeed financially, but many don't. And there are also big blockbuster films with only average rating. So quality helps, but it definitely doesn't guarantee high box office performance. Metascore gross. Here the correlation is typically even weaker. Metascore reflects critic opinion, not popularity. It's very common to see critically acclaimed films with low box office numbers and commercially successful movies with mediocre critic scores. Uh, Finally, rating and runtime. This correlation is small as well as the previous one. The longer movies sometimes allow more character development, uh, which can lead to higher rating, but many shorter films are highly rated too. Overall, runtime is not strong predictor, of course. It's not a strong predictor of audience rating. That's all about explain. Let's run it. It's year and gross. Year versus gross. Year versus runtime. Year runtime versus gross. IMDb rating versus gross. Metascore versus gross. And IMDb rating versus runtime. And here's our correlation. Rating and runtime. It's just last one. No, there's also correlation. Yes. This part. This part. This part. It is minus. It's I am rating versus runtime and the correlation output. That's all about it. Thank you for your attention.